Hello students, welcome back to Engineers Academy. Do subscribe Engineers Academy if you haven't done it yet. Now let's solve this problem from Hibbeler dynamics, and the problem says that the missile at A takes off from rest and rises vertically to B. So we have this missile and it travels from A to B in the vertical direction, and it takes 8 seconds from A to B. And it is said that if the acceleration varies with time is shown, so here it is shown that the acceleration varies with time like this, that is the straight line. So it is said that determine the missile's height hb and speed vb. So we have to find this hb from A to B, the height, and the velocity at B. So first let's solve this part and then we will continue for this part of the problem. So first of all, it is said that the missile takes off from the initial velocity. So let's say that the initial velocity is at A, so VA is 0, and we have to find VB, and we have to find the height of the missile when it is at point B. And we are given the acceleration as a function of time. So now we can say that for time interval greater than equal to 0 and less than equal to 8 seconds, we have to find the equation of this straight line. So acceleration varies with respect to time, and that is represented by this straight line. So now we can say that this is it will have the equation of a straight line, and as we know that the equation of a straight line is y is equal to mx plus b, while b is the y-intercept. So now as we can see that this acceleration with respect to time, this line is intersecting with the y-axis at the origin. So this means that the y-intercept is 0. So this means that this b is 0. So let's eliminate this. Now we have to find the slope. So m is the slope. So the slope of this line is the rise divided by the run. So now the rise is 40 minus 0. So this is 40 minus 0, and the run is 80 minus 0. So this is this is 8 minus 0, right? So we will write that this is 8 minus 0. So this is 40 divided by 8, which gives us 5. So now on the y-axis we have acceleration. So let's replace this y with acceleration. So this is a. The slope m is 5, and on the x-axis we have time, right? So this x will be replaced by time. So the acceleration is equal to 5t. So when the missile travels from A to B, the acceleration varies like this. This is acceleration is equal to 5 times t. So now we have to find the hb and vb. So now as we know that the acceleration is dv by dt, and this will be equal to 5t for this particular interval, and from this equation we can write that dv is 5t dt. So let me write that this is dv is 5t dt, and now let's integrate this. So we will integrate this from initial velocity, which is 0 to v, and this will be from 0 to t. So this will give us, this will cancel out and we will get v minus 0. So this is v, and this will be 5t square divided by 2 from 0 to t, and if you put these limits we will get 5 divided by 2t square. So now if you want to find vb, the velocity of the missile at point B after t equals to 8 seconds, right? So we have to put t equals to 8 seconds in this equation. So this is 5 divided by 2 is 2.5 multiplied by 8 square. This gives us vb equals to 160. So now vb, which was required, is equal to 160 meter per second. And then from this equation we can say that the velocity is ds by dt, and 5 divided by 2 is 2.5 t square. So we have the same equation, and velocity is replaced by ds by dt, and if we multiply both sides of equation by dt, so we will have ds equals to 2.5 t square dt, and then we have to integrate this. So now we have to integrate this from 0 to s, and this is again from 0 to t. So when we integrate this will cancel out, we will be left with s, and if we put limits, that will be s minus 0, and this is 2.5 t to the power 3 divided by 3, and this is from 0 to t. So ultimately we will get s, that is 2.5 divided by 3 t to the power 3. So now we have to find hb. So in 8 seconds the missile travels a distance of hb, so we can say that the distance traveled in 8 seconds is hb. So that is 2.5 divided by 3, and we have to put t equals to 8 seconds. So this is 8 to the power 3. So this is 2.5 multiplied by 8 to the power 3 divided by 3. So this gives us 427 approximately. So this is 427 meters. So after 8 seconds, the missile has a velocity of 160 meters per second, and it travels a distance of vertical distance of 427 meters. So now let's say if this is my origin of the Cartesian coordinate system. At point A we have the origin. So then the coordinates of the point B is 0 and 427, since this HB is 427. So the missile is along the x, it is at the origin, but it has traveled a distance in the vertical direction, which is 427. So the coordinates of point B is 0, 427. Now we have determined VB and HB. So this was the first part of the problem, and then the second part of the problem says that if by internal controls the missile is then suddenly 0.845 degree is shown and allowed to travel in free flight, determine the maximum height hc and the range r to where it crashes at d. So after point B the missile travels as a free flight, right? It's a free falling body, right? And the missile travels along this direction, and the velocity makes 45 degrees. So then we can resolve this VB into its components, right? So we will have, since it's moving like a free falling body, so it will have a projectile motion. So for projectile motion we have to resolve this VB. So we will have two components. So this one will be VBX and this one will be VBY. So now as we can see that if this is VB and VB is making 45 degrees, then VBY is the cos component. So we can write that VBY is VB cos of 45, and similarly VBX is the sine component. So this is VB sine of 45 degree. So let's say that VB y is VB cos of 45 and VB is 160. So we will write 160 cos of 45. So this is 160 cos of 45. This is approximately 113.14. So this is 113.14 meter per second, and similarly VBX is equal to 160 sine of 45, and this will also give us 113.14 meter per second, since sine of 45 and cos of 45, their values are equal. Now first of all we have to find the maximum height hc. So we have to find this maximum height hc. So when the missile is at point C, we have to find the coordinates of this point C. So let's say that the missile is at a distance of x and at a height of hc. So from the origin its coordinates will be x and hc. So now to find hc we have to consider the vertical motion of this projectile. So let me write that we are considering the vertical motion from B to C. So now from B to C we can say that 2g yc minus yb, this will be equal to vc square minus vc square minus vb square. Now the vertical velocity, since we are considering the vertical motion, so at point C the missile is only moving in the horizontal direction, so the vertical component of the velocity will become 0. So we can say that this will become 0, right? We can write that this is vcy square and this is vby square. Since we are considering the vertical motion, so we are going to consider the vertical components, right? So this means that vcy, this will become 0. So, and further, as we can see that when the missile is moving in the upward direction, the velocity is decreasing. So if the velocity is decreasing, the acceleration is negative, right? So we can say that this is 2, g value is minus, since it is deaccelerating in the upward direction. So we can write that this is g is minus 9.81, and now yc is the y coordinate of the missile at point C. So yc is hc, right? So we can write that this is the vertical coordinate of the missile at point C. So this is hc, and the vertical coordinate of the missile at point B is hb, which is 427. So we will write that yb is 427, and this is minus, and now vby. So now we know vby, which is 113.14. So this is 113.14 square. So now we can find hc if we divide both sides of equation by 2 into minus 9.81. 2 into minus 9.81. So this will cancel out. So we will be left with hc minus 427, and this will be equal to, so this is minus 113.14 square divided by 2 into minus 9.81. So this gives us 652.43, and if I add 427 to both sides of equation, so this will cancel out and we will have plus 427. So we can say that hc is equal to 652.43 plus 427. So let's add this 652.42 with 427. So this hc is the maximum height the missile travels is 1079, approximately 1079 meters. So this is that maximum height. So this hc is 1079 meters. Now in the next part of the problem, it is said that determine the range to where it crashes at D. So we have to find this horizontal distance. This horizontal distance is known as the range, so we have to find this r value. So now let me copy this image, and we want to find that range. So again we are going to consider the vertical motion from B to D. So let me write that we are considering again the vertical motion of the projectile from B to D. So again we can use this same equation, or we can use we cannot use this equation since we know the since we do not know the velocity at point D. So we have to use that equation, that is yd minus yb, and this is vby into tbd plus 1 divided by 2 g into tbd square. So tbd is the time taken by the missile from B to D. So this is tbd, and this is the final coordinate, the y coordinate of the missile at D, and this is the initial coordinate, the vertical coordinate of the missile at B. So now as we can see that the coordinates of point D will be r, since the distance from the origin in the horizontal direction is this r. So the x coordinate will be r and the y coordinate will be 0. So we can write that this is r0. So now this is yd and this is yb. This is the y coordinate y coordinate of the missile at B and the y coordinate of the missile at D. So this is 0 minus 427, and again VBY is 113.14. TBD is not known, the total time taken by the missile to travel from B to D, plus 1 divided by 2. And since we are considering that this direction for the velocity is positive, and in this direction the missile is deaccelerating, so G value is minus 9.81 and TBD square. So now let's find, we can bring this 427 to the other side of equation. So let me rearrange this equation. So we will have 1 divided by 2 into minus 9.81 TBD square plus 113.14 TBD plus 427. So this is a quadratic equation. Let's say that 9.81 divided by 2, this gives us, this is minus 4.905 TBD square plus 113.14 TBD plus 427. This is equal to 0. So this is a quadratic equation in terms of the TBD, which is the time taken by the missile from B to D. So we can solve this quadratic equation for the positive root, and that will give us the time which the missile will take to travel from B to D. So now let's solve for this polynomial. So we will have the coefficient of TBD square is minus 4.905 and the coefficient of TBD is 113.14 and the constant is 427. So this gives us TBD equals to 26.37, let's say approximately 26.37 seconds. And the second root is negative, so time cannot be negative, so this is the time taken by the missile from B to D. So now once we know the time taken by the missile from B to D, we can find the range. So if we consider the horizontal motion now, so as we know that for a free falling body which is moving with projectile motion, we can say that the acceleration in the horizontal direction, this is always equal to 0, since the horizontal component of the velocity remains constant, right? So we can write that the xd minus xb is equal to vbx times t plus 1 divided by 2ax into t square. So since ax is 0, so this will become 0. So we are left with this equation, and this is xd. Now the x coordinate of the projectile at point D, so the x coordinate is r. So xd can be replaced with r, and the x coordinate of the missile at point B, so the x coordinate of the missile at point B is 0. So this is 0, r minus 0. And VBX is again 113.14 into, this will be TBD, since if we are going to find the range, so in order to travel that horizontal distance, the projectile is taking 26.37 seconds, so we are going to consider this as TBD. So this is multiplied by 26.37. So now this is 113.14. Let's convert the mode of this calculator to simple mathematics. This is 113.14 multiplied by 26.37. So this gives us, this is 26.37. So this is 2983. So the range is approximately 2984 meters, or we can say that this is 2.98 kilometers approximately. So the projectile travels a distance of 2.98 kilometers in the horizontal direction before it crashes. So this is the solution of this particular problem. I hope it will help you in your learning. Do subscribe Engineers Academy if it helps in your learning.